Welcome to Lecture 4 on creativity and puzzles. In this lecture, we're going to talk about what we know about creativity and the brain. Although everyone agrees about the value of creativity, until recently, we knew little about how the brain processes it and what processes are underlying it. Now, different brain areas are specialized for different functions. Listening to my voice, for instance, involves the temporal lobes. Watching me, the occipital lobes. Thinking about my lecture points, you use your frontal lobes. And your emotional responses to my words involve the right hemisphere and the limbic system. Now, you may have heard that the two hemispheres are specialized. The left is more important for verbal and symbolic processing, and it's the main language center for reading, writing, speaking, and calculation. It also analyzes the right visual field and controls the right hand. Now, the right hemisphere is important for processing visual spatial information, such as reading a map or driving in unfamiliar surroundings. It's also involved with emotional perception and expression. It gives the emotional coloring of language. For instance, sarcasm, where we say something like, "He's a real brain," being sarcastic, as opposed to, "He's a real brain." It also analyzes the left visual field and helps control the left hand. Now, the independent operations of the hemispheres was first demonstrated years ago in patients whose corpus callosum had been severed as a treatment for epilepsy. The corpus callosum connects the two hemispheres. But the difference in right and left hemispheric styles has been exaggerated in normals. Each of us, in fact, has a unique cognitive style that blends the functions of both the left and the right hemisphere. Now, the brain uses the most appropriate hemisphere for a specific task with assistance from the other hemisphere. For instance, the right hemisphere is not the language hemisphere, but it can do a little bit of reading. So we have an important principle here. You can increase efficiency by activating different rather than similar brain areas. For instance, when you're on the telephone and someone brings you a note, it's a lot easier than if they just come up to you and talk to you while you're on that phone. This avoids the interference effect, where the hemisphere functions interfere with each other if activated together. It's best, therefore, to arrange things so that you aren't calling on the same brain areas at the same time, lest they interfere with each other's performance. For instance, when driving, don't try to read road signs while engaged in a spirited conversation. Instead, use a GPS, which would not interfere as much because you're simply looking at it. Now that we know something about brain geography, let's see how we can use that knowledge to enhance our creativity and even have some fun in the process. Here's our first exercise. Add one mark or symbol to the above Roman numeral and change it to the number 6. Now, since 9 is a Roman numeral, you may be predisposed to think in terms of Roman numerals. Instead, think in terms of other symbols, letters, or numbers. So what symbol, letter, or number would change the Roman numeral 9 to the number 6? Well, it would be the letter S, of course. The answer is to add the letter S to produce 6. So that's S plus the Roman numeral 9. The riddle was solved either by an immediate grasp of the situation, you saw it right away and you had the correct solution, or you kind of reasoned your way around it, or you examined assumptions and got rid of this assumption that had to be a Roman numeral. Creativity is often marked by sudden insights, the experience, which is a nearly instantaneous resolution of insight that's associated with a sudden burst of activity in the right anterior temporal area, which provides proof that creativity is brain-related. Now, creativity is based on 3 thinking patterns. The verbal language, in which unwarranted assumptions can trip us up, as happened with that 9-6 riddle I gave you a moment ago. The second is music and math. Now, this, of course, requires the understanding of fundamentals. We have to know something about math, we have to know something about music. So it's dependent on specialized training. The third thinking pattern is visual thinking. And this is often the key to creative thinking. by envisioning and manipulating information. Now let's look at what's happening in the brain when you come up with a creative solution to a problem. First, there's an increased involvement of the right hemisphere, especially the temporal lobe. Second, there's an increased use of the frontal lobes, which are critical for divergent thinking and the co-activation of widespread neuronal circuits. Third is a change in the neurotransmitter system, a modulation of the influence of norepinephrine and the achievement of what we call a power-down state, such as rest, relaxation, sleep, especially dream sleep. Real ideas came to me, this is Bernard Berenson, the art historian, he stated, real ideas came to me while relaxed and brooding in a meditative, passive way. Then the unexpected happens, an illumination, a combination of words, a revelation for which I had made no conscious preparation. Now we're talking here of mind wandering, also known as daydreaming. That's an everyday power down state. And of course, it's traditionally frowned upon, but it's also very common. 30% of people admit to mind wandering. Do you? If so, there's nothing wrong with it. It functions as an escape from boredom, for one thing. James Thurber's story, The Secret Life of Walter Mitty, featured a middle-aged man who escaped from boredom by daydreams of himself as a military officer, a brilliant doctor, a heroic bomber. Mind wanders, incidentally, score high on creativity. When the mind wanders, the brain's executive centers are activated along with a default network. Combination of these two networks may explain the link between the mind wandering and creativity. As a practical solution, let your mind putter around a bit so your brain is free to wander productively. But don't overdo mind wandering. It's best in small doses. According to Jonathan Schooler, a researcher on mind wandering, you need to allow your mind to wander if you want to be creative, but you also need to notice that you are mind wandering and catch the creative idea. Now, creative insights emerge from power down states, as I mentioned a moment ago. Especially important is the contribution of sleep with or without dreams. Let's discuss 3 examples. The first is August Kekul's dream of the benzene ring. The second was Otto Louis' dream leading to the discovery of the neurotransmitter acetylcholine. And the third was an experiment carried out by William Dement. Now, August Kekul was the discoverer of the chemical structure of the benzene ring with 6 carbons and 6 hydrogen atoms. He had a dream of 2 intertwined snakes biting their own tails. The dream was based on a grand jury testimony during a murder trial many years earlier. He had been asked to give some testimony. Among the deceased belongings was a signet ring fashioned in the shape of 2 intertwined snakes biting each other's tails. His unconscious memory of this dream, of this experience rather, was revisited in his dream and gave him the chemical structure, namely a 6-layered arrangement composed of carbon and hydrogen suspended like charms from a bracelet. The second example is Otto Louis. He believed that the slowing of the heart was caused by a chemical rather than just electrical stimulation. He tried several experiments but wasn't able to demonstrate that. And one night he had a dream about how to do it, and he woke up and went to the lab. He set up 2 frog hearts and stimulated the vagus nerve of the first heart, and then drew off some of that fluid surrounding the heart. He added that fluid to the fluid surrounding the heart of the second frog. That heart too slowed down. We now know that acetylcholine was the chemical released by the nerve cell stimulation of the first frog's heart, and that caused the slowing of the second frog's heart when it was applied to that heart. In the third example, William Dement, the sleep researcher, asked his students this riddle. Consider the letters H-I-J-K-L-M-N-O. Now this sequence should suggest one word. What is that word? Some of the students got it right away. Other ones didn't, and he asked them to dream about it and come in the next day and tell him about their dreams. The students dreamed of hunting sharks, skin diving, being caught in heavy rain. Does that give you a hint? We're talking about the chemical formula for water, H2O, is the answer, which is the letters H to O in the sequence. Now, 4 steps can be used to increase creativity. One is to focus on the problem until you really understand it. Mentally put your assumptions into words. Make certain you understand what you must do to reach a solution. And ask yourself, in other words, what ways can I think about this and envision this problem in a different way? Now, both creativity and divergent thinking involve fluency, which is rapidly producing multiple possible solutions to the problem. Elaboration, which is thinking through the details of the problem. Third, flexibility, which is entertaining multiple approaches to the problem simultaneously. And finally, the fourth is originality, which is coming up with ideas that don't occur to most people. Now, creativity employs divergent thinking, which is linking up based on associative memory and novel concepts. It involves the recruitment of distributed cell networks, which leads to seeing beyond the obvious. It involves filtering and employing an evaluative attitude. In other words, the art and science of the possible. You're not thinking of things that are totally impossible, they've got to be reasonable. Third is the use of a modular versus a linear design, thinking in terms of a mosaic in which something might have to be moved rather than a tightly bound narrative. Now, the goals for divergent thinking are, number one, to achieve a spontaneous, random, unorganized, now not disorganized, but unorganized and free-flowing manner of thinking. Goal 2 is to loosen the control of the left hemisphere and allow the emergence of less structured, nonverbal material to emerge from the right hemisphere. Now, the methods for that are like keeping a journal, brainstorming, mind mapping, and free writing, which means just taking out a journal and start writing as quickly as you can about what things come to mind. Now, one way to enhance brain function is through creative play. Puzzles, word games, and humor are marked by uncertainty and ambiguity, which tests our brains in unaccustomed ways. We tend to resist not having answers to questions that are asked us, which leads us to premature closure, which is reaching a conclusion or accepting an explanation before examining the facts and the logical conclusions flowing from these facts. In fact, all of us jump to premature and erroneous conclusions. Here's an example. Let me introduce you to Stan. Stan tends to be shy and likes to keep to himself. His apartment is always neat and tidy, typical of his need for order and structure and attention to detail. Let me ask you this question about Stan. Based on that description, is Stan more likely to be a librarian or a farmer? Many people would select librarian despite several important considerations. Statistically, there are many more farmers than librarians. Words like shy and neat and tidy activate stereotypes about librarians, and as a result, we may be less likely to associate these adjectives with farmers than librarians. In our desire for a quick answer and the resolution of ambiguity and uncertainty, we trust in stereotypes. We ignore statistics such as the base rate, that there are more farmers than there are librarians. In fact, Stan's description of the character of a librarian is written by a movie screenwriter unacquainted with many librarians. What's called for in deciding about Stan's occupation was the willingness to avoid premature closure and examine the data. Let me give you another example. Champagne will keep its fizz overnight if a spoon is suspended in the neck of the bottle and the spoon does not touch the liquid. Why is this? Now, that was a question written to the last word column of The New Scientist. Now, to the editors, the proposal seemed preposterous and unreasonable. But in the interest of not appearing narrow-minded, they decided to test it. It worked for 12 hours, with even some fizz after 24 hours. Now, was this a mysterious insight about spoons and champagne? Well, the editors tried a second experiment and asked volunteers to blind taste champagne left overnight with and without a spoon. They found that the spoon had no effect. An incorrect assumption was at work here, and that is that champagne quickly goes flat if not corked. Actually, it takes about 96 hours before it goes completely flat. You can try that for yourself. You can use a bottle of cheap champagne, of course. The bottom line is that there's no unexpected longevity overnight, and thus the spoon had nothing to do with the findings. We have to train our brain to break through its tendency to leap to premature closure based on seemingly reasonable but incorrect assumptions. A suspension of premature assumptions and judgments is also required for the successful solving of puzzles. Puzzle creators like Scott Kim and David Book ponder for weeks a puzzle's possible solution. They actively resist premature closure. Let's explore how we might do the same. Think back to the brain processes involved in solving the librarian-farmer question. We relied on our memory based on our past experiences about farmers and librarians. We analyzed the question, the description of Stan. We used our verbal reasoning. We used logic, trying to make sure everything logically followed. And of course, we had to keep moving it around in what we call working memory so we could remember all the components. We also had to have a critical analysis to identify stereotypes, because stereotypes is what threw us off. In this lecture, I'm suggesting that you embrace ambiguity as a means of enhancing your brain. Puzzles are uniquely appropriate for this. Try this puzzle. Rearrange the letters in the two words new door to make one word. But before rearranging the letters, consider exactly what I requested you to do. Now simply do it. You're probably thinking of some way to rearrange the letters to come up with a novel word. You're probably rapidly going through all the various possibilities, either alphabetically or maybe you're just guessing. In fact, the answer's easy. In fact, I've already told it to you. New door becomes one word. The brain thrives on thinking of things in different ways, and puzzles are prominent ways and preeminent ways to do this. Here's another one. What occurs twice in a moment, once every minute, yet never in a billion years? To solve it, forget about analyzing units of time. Think in terms of the words and the letters. Moment, minute, and a billion years. The answer is the letter M. Puzzles can be divided into two types. Those solved by planning, deciding, evaluating, in other words, the operations of the frontal lobes. And secondly, those solved by a sudden insight, the eureka moment when the answer just comes to us in a flash. That involves the anterior temporal lobes, which fire 1/3 of a second before insight. So brain activation actually precedes conscious insight into the answer to the puzzle. So here's a question for you. Who solved the puzzle? Here's another puzzle. At opposite ends are my mouth and my head. I run for miles without leaving my bed. What am I? The sentences are paradoxical, aren't they? Mouth and head at opposite ends. The words must have several meanings. Keep thinking about it. Keep your unconscious riddle-solving machinery on the job, as David Book puts it. Think again. What's the answer? We're talking about a river. So develop an interest in word games. We are verbal creatures and our brain thrives on words. As we learn new words, we expand our mental horizons. We can add extra benefit by playing with words. The book I wrote with Scott Kim, The Playful Brain, uses puzzles to stimulate and optimize brain function. Word puzzles call on our left hemisphere, which mediates words and language. And word puzzles stimulate the unique language areas in novel ways. We must come up with new and creative arrangements of words. Crossword puzzles are especially effective at making us think of words in uncommon ways. As an example of a fun word puzzle, have a friend cut out the words from the captions of a cartoon and rearrange them. Then see if you can restore the punchline by putting the words back in their correct order. Here are 3 examples taken from a single issue of The New Yorker. So when you encounter a cartoon, look carefully at it and think about what's represented there before reading the caption. The New Yorker routinely provides cartoons without captions and challenges the readers to provide the caption. Puzzles involving cartoons strengthen the brain's ability to switch points of view and think about things in unusual ways. They also challenge the brain to work with ambiguity and uncertainty. As another word challenge, have someone cut and scramble the frames of a comic strip and then see if you can rearrange them into their correct order. This exercise tests your ability of problems, your sense of timing and logic. After you've mastered these single puzzles, mix 2 or 3 of them together. This comic arrangement exercise is similar to the basic skills we use when we make plans, tell stories, and anticipate the likely consequences of certain actions. Now, this is primarily a frontal lobe exercise involving timing, sequencing, organization, and executive control. This is similar to the skills needed for sticking to budgets, planning a party, telling a story, or a joke. So how do we solve puzzles? Here are several approaches that Scott Kim suggests in our book, The Playful Brain. First, try something. Just getting started may be the hardest step. Even a wild guess is fine because figuring out why the guess doesn't work helps you to decide where to focus your efforts. Second, persist. The biggest reason for not solving puzzles is giving up. If you feel you can't persist any longer, then look up the answer. And incidentally, looking up the answer isn't cheating, but simply helping your brain learn principles that will be useful in future puzzles. To understand why the answer was correct, and then imagine how you might have gotten the answer yourself. How to understand and solve form puzzles. I've always had trouble with form puzzles. These are puzzles where you have pieces that are together, like in this box. I can take them out and then you have to try to rearrange them. Not so easy, actually, unless you have a lot of experience with it. Such puzzles almost entirely involve the right hemisphere. Putting things into words, which come more naturally to me, doesn't help. In fact, it often hinders. How to solve such a puzzle? With the puzzle in place, I use a digital camera to take a picture after I remove one piece at a time. Later, if I get stuck when I'm working the puzzle, I look at the pictures in reverse order. I'm now better at solving such puzzles. This is a good example of Scott Kim's point that we aren't cheating when we look up an answer, but as long as it helps us to organize ourselves and organize our brain. It's also an example of the use of technology to enhance brain function. Other suggestions are to set time limits. The brain responds best with a set time limit. The brain can almost always work faster if you ask it to. Now, this is the opposite to multitasking. You're doing only one thing, but you're doing it faster. We're talking here about brain programming, which is setting a performance goal for the brain and then allowing the brain to fulfill that goal. For instance, I have a habit of trying to write between 500 and 1,000 words a day. Don't always do it, but I prominently display the time available for me to finish that session. Here's another idea. Use brain teasers to enhance concentration and visual thinking as creativity. Here's one of my favorites. You're in a room with 3 light switches that turn on 3 light bulbs in another room. You can turn on only 2 of the switches and you're allowed only 1 trip into the room to check which 2 light bulbs are on. How do you decide which switch turns on which bulb? I'll say it one more time. You're in a room, 3 light switches that turn on 3 light bulbs in another room. You can turn on only 2 of the switches and you're allowed only 1 trip into the room to check which 2 light bulbs are on. How do you decide which switch turns on which bulb? Now, there's an unwarranted assumption here, a premature closure. Light bulb and lights and turn on suggest a visual approach. But think about what other senses might be even more helpful in solving the problem. Think of touch. the most primitive sense actually, but it will provide the solution. Have you come to the solution yet? Turn 2 switches on for 10 or more minutes. Turn one of them off, go into another room. The bulb that is still lit is controlled by the switch you left on. Now touch the other 2 bulbs. The switch you turned off controls the warm one. The third switch controls the other light bulb. Puzzle's like a koan. Keep thinking about it. Mull it over in your mind until it becomes as familiar as the feel of a favorite stone. Then forget about it for a while. Return to it at odd moments. Think of it before going to sleep, and you may dream about it, as with the William Dement dream puzzle. Let's try a puzzle from David Book's Problems for Puzzle Busters. From this diagram of 8 quarters laid out in the shape of an L, change the arrangement so that there are 5 quarters in each leg of the L. Now, horizontal rearrangements don't work. You have to think vertically instead of horizontal. You know, the answer is to place one of the quarters from the long arm of the L and place it on top of the quarter in the corner. Why do puzzles? They strengthen your capacity to concentrate and mull over problems, question initial assumptions, restate and reframe problems. You can shift your mental perspective. In fact, you have to. You can integrate brain function by uniting the activity of the right and left hemispheres. And by doing all of these previous things that I mentioned, you can achieve creative solutions. Now, approaches to puzzles involve think of the words in unaccustomed ways. What associations are aroused? What do the objects of the puzzle have in common, and where do you find them? Do they have any parts in common? How can I reorient my thinking? Humor is also important here, because jokes require a similar reorientation. For instance, a gymnast goes to an instructor and says, "Can you teach me to do splits?" And the instructor says, "I think so. How flexible are you?" The gymnast says, "I can come any day but Wednesday." Now, this is an example of the incongruity resolution theory. While the setup elicits one line of thinking, the punchline hits us with a different way of thinking. The frontal lobe plays an active role in the flexible thinking required to get a joke. Frontal lobe damage destroys that flexibility, and a person becomes humorless and literal, as when the doctor says to the patient, "What brought you to the hospital?" The patient says, "The ambulance." Now, sometimes this literalness can be used as the basis for a joke, as with the humor of Stephen Wright. Here are 2 examples. Everywhere is walking distance, if you have the time. Secondly, I saw a bank that said 24-hour banking. I don't have that much time. The prefrontal cortex in such situations picks up on the incongruity and sends signals to the supplementary area and the nucleus accumbens, leading to delighted surprise accompanied by laughter. Now, in depressed people, frontal lobe interactions with those structures are decreased. As a result, humor is regained only with some treatment, which can help. Humor can be used therapeutically. It increases arousal levels and skin conductance, and most important, makes the depressed person laugh. Bottom line, puzzles and riddles and jokes enhance the brain by encouraging reasoning, logic, visual imagination, spatial thinking, working memory, and creativity. Equally important, puzzles, riddles, brain teasers, and jokes are just plain fun. In later lectures, we'll be talking a lot about memory. There's the memory-imagination link. A poor memory function is linked with impoverished imagination. This is a new insight, incidentally. Similar networks are activated by remembering and imagining. We'll learn how to use memory exercises to foster imagination and vice versa. Thus, as you improve your memory, your creativity should improve as well, along with concentration, sequencing, facility with numbers, and auditory and visual short-term memory. Before we dive into our memory exercises, we need to learn something about how to focus our attention, which is the basis of improving memory. That's the subject of our next lecture. Thank you.